FastMCP3's component registration system employs a decorator-based pattern to define and store tools, resources, and prompts directly within the server's local provider. This mechanism ensures that locally defined components take precedence during resolution, leveraging Python's decorator syntax for concise and declarative registration. We will now examine how these components are implemented using the @MCP tool, @MCP resource, and @MCP prompt decorators, each serving distinct roles in the system's architecture. The upcoming code snippet demonstrates the straightforward initialization of these components, highlighting their type signatures and minimal functional implementations.
@MCP tool, def my tools, int str, return strx, @MCP resource data / info, def my resource str, return info, @MCP prompt, def my prompt topic str, return f discuss topic.
This code demonstrates FastMCP3's component registration system using decorator-based syntax. The three core component types are shown: @MCP tool for executable functions, @MCP resource for data endpoints, and @MCP prompt for template generation. Each decorator registers its function with the server's local provider, making them immediately available for client requests. The pattern follows a declarative approach where components are defined as regular Python functions with type hints, then enhanced with metadata through decorators. This design choice prioritizes developer experience by keeping implementation simple while adding framework-specific capabilities. The data / URI scheme in the resource decorator indicates this is a virtual data endpoint rather than a physical file path. The trade-off here is between simplicity and flexibility. While the decorator approach is clean for basic cases, more complex scenarios might require the direct method registration shown in the additional context. The type hints provide both documentation and runtime validation, though they're Python's standard typing rather than framework-specific constraints. This balance makes the components portable while still being framework-aware. Let's break it down.
@MCP tool, def my tools, int str,
defines a function named myTool decorated with @MCP tool, indicating it's registered as a tool in the FastMCP framework. The function takes an integer parameter x and returns a string. The decorator suggests this function will be discoverable and callable as a tool within the FastMCP ecosystem, though the specific implementation details aren't visible in this segment.
Return strx
converts the value of variable x to its string representation and returns the result.
@MCP resource data / info
decorates the following class or function with the @MCP resource decorator, specifying the resource path data / info as the target location for this resource in the FastMCP3 system. This establishes a direct binding between the decorated component and the data / info resource endpoint, enabling automatic resource registration and management by the framework.
Def my resource str
defines a function named myResource that returns a string value. The function takes no parameters and is declared with a return type annotation, indicating it will produce a string output.
Return info
returns the string literal info as the output of the current function or method.
@MCP prompt, def my prompt topic str
defines a prompt function named myPrompt that takes a string parameter topic and returns a string decorated with @MCP prompt to indicate it's a specialized prompt handler in the FastMCP3 framework. The decorator suggests this function will be used for prompt processing, while the type hints specify it expects a topic string and produces a string output.
Return F discuss topic.
Returns a formatted string that starts with discuss, followed by the value of the topic variable. This creates a simple prompt or label for discussion purposes, combining static text with a dynamic topic value. FastMCP3's decorator-based registration system provides a clean, declarative way to define and manage components through @MCP tool, @MCP resource, and @MCP prompt. Each decorator binds its function to the local provider, ensuring local components take precedence during resolution. The pattern prioritizes simplicity, using standard Python functions with type hints, while adding framework-specific capabilities through metadata. The trade-off is clear. While the decorator approach keeps basic cases elegant, more complex scenarios might need direct method registration. The data //URI scheme and resources highlights the framework's virtual endpoint system, distinguishing it from physical paths. Together, these components form a cohesive architecture where tools execute logic, resources serve data, and prompts generate templates, all discoverable and managed uniformly by the framework. The design balances portability with framework integration, using Python's native typing for both documentation and validation.
The decorator wraps the tool in silence, while the resource shouts the prompt into a black hole.